Welcome everybody. This is another question I want to give you all involving number theory. Now we are expected to find the remainder when 2018 raised to the power of 2018 is divided by 20. Now this is a very popular question and it has appeared in several competitive exams. And furthermore, all that they would do if they want to ask a question of this nature, they will just change a year. So I will work this question out for 2018 and you can follow the same suit. So foremost, what I wish to do is I would like to write down 2018. Now, can I divide 2018 by 20? Of course I can divide. Now, by long division it's okay, but by modular division I need to place in the remainder here when I am performing modular arithmetic. In other words, I want to place the remainder over here when 2018 is divided by 20. Now the question is, what should be that remainder? Now for that, what you need to do is find out the closest value that is completely divisible by 20. In case of 2018, the closest value would be 2020, but 2020 is actually greater than 2018. In other words, you will have to add some quantity with 2018 so that you are getting 2020. Now the question is, what would that quantity be that is required to make 2018 as 2020? What's your answer? Definitely you need to add 2. If you add 2, you would get 2020. In other words, take that 2 and place it over here with a negative sign. Now what are you trying to say? You're trying to say to the reader, if I were to push this negative 2 over to the left hand side, then it would become 2020. And clearly 2020 is divisible by 20, leaving the remainder 0. So in Brubity, find out that quantity of number which is required to ensure that this quantity which is given is perfectly divisible by 20, thereby leaving us the remainder 0. So that should be your quest. So in this case, negative 2. If I were to add the 2, I will get 2020, and 2020 is perfectly divisible by 20. So I hope you got that essence. Now, having got that, have this in one corner of your mind. Now what you need to do is go back and write down the value 2018. Right, 2018 raised to the power of 2018. Now what have you found here? You have found that 2018 is congruent to negative 2 mod 20. So now what you need to do is place that negative 2 here and raise to the power of 2018. Now can I write 2018 as 2 times 1009? Of course, 2 multiplied with 1009 will give me 2018. So I can always do that. Now from the law of indices, a raised to the power of m raised to the power of m can be rewritten as a raised to the power of n times m, which can also be rewritten as a raised to the power of m, the whole raised to the power of n. So there are so many ways by which we can write using exponential rule. So this quantity over here is going to be rewritten as negative 2 raised to the power of 2 like this, which in turn is raised to the power of 1009. Negative 2 raised to the power of 2, what would you get? That's going to be 4. This is raised to the power of 1009. Okay, fair enough. Now go back here. This is actually, you need to divide this by mod 20 and get the remainder. That is what the question wants. Now before we could head, find out what happens when you divide 4 by mod 20. What would you get? 4 divided by mod 20. Is it possible for us to divide 4 by mod 20? No. So So we write it as it is. Now 4 squared is equal to what? 16. Now is it possible for us to divide 16 by mod 20? Now the question is, I'm following a specific pattern, and that's the reason I'm placing in the steps. Now 16, right? Now this is actually 4 squared. 4 squared is rewritten as 16. Now the question is, what should you place? What is the nearest value that you need to place, or you need to add to 16 so that you get a value which is perfectly divisible by 20? What should that value be? That value should be 4. And if you want to place that value that is falling short, you need to place it like this, negative 4. When you push it, it becomes 16 plus 4 is 20. 20 is easily divisible by 20. So that's the way you need to write. So you see that for 4 you're getting 4. For 4 squared you get negative 4. Now let me take in 4 to the power of 3. What is 4 to the power of 3? That's nothing but 4 times 4 squared. Now what is this? This is congruent to, when I add 4, I add a 4 here. 4 has been found to be congruent to 4 mod 20. So for this 4, I got a 4. And 4 squared, this is 4 squared, that is congruent to negative 4. 4 into negative 4, what do you get? You get negative 16. Now you have a negative 16. The question is, what should you place over here? So that number added with negative 16 is easily divisible by 20. That should be the closest value to negative 16. So clearly, if I were to place positive 4 mod 20, because positive 4, when it comes over here, it becomes negative 4. So negative 4 added with negative 16 will become negative 20, which is divisible by 20. So fair enough. Now study the pattern. When it is 4 raised to the power of 1, I got it to be congruent to 4 mod 20. When it is 4 raised to the power of 2, I got it to be congruent to negative 4 mod 20. When it is 4 raised to the power of 3, I'm getting it positive 4 congruent 20. Now let me show you what happens if I get 4 raised to the power of 4. 4 raised to the power of 4 can be written as 4 squared times 4 squared. Now 4 squared is congruent to negative 4, and this 4 squared is congruent to negative 4. 4 into 4 is 16. Now 16 is congruent to negative 4 mod 20. If I had to push this negative 4 to the other side, to the left side, I would get 20. 20 is congruent. It's congruent to 0 mod 20. It's perfectly divisible. So as I mentioned to you, for 4 cubed, you get positive 4. Now 4 raised to the power of 4, you get negative 4. Now observe that when the powers are even, you get negative 4. When the powers are odd, you get positive 4. Positive 4 over here, positive 4 over here. Now apply the same concept. So what have you got here? You got 4 raised to the power of 1009. And you need to find to what element that you need to place here, so that could be the remainder when 4 raised to the power of 1009 is divided by 20. Now clearly you have seen this is the odd number, and for odd number, whenever the exponent is odd, you got the value to be congruent to 4 mod 20. So just place that 4 mod 20. In other words, when 2018 raised to the power of 2018 is divided by 20, the remainder is equal to 4. So that is the solution for this question. This is indeed a beautiful question. I hope you enjoyed this question. Thank you, everybody.